Hello everyone. Today I am going to present my minor project which is on distributed Linux kernel attestation framework which I have developed. It is basically a three-layered architecture which helps in a huge gap that is in present with the runtime checking in a secure boot enabled mode. So the current model says if we are checking the kernel verification at the start of a operating system or when the UEFI architecture boots up, but there are no solution present with the runtime integrity checking. So we have worked on that and we have a solution with us which is three-layered architecture which consists of three things. Which first one is kernel node. So what do you mean by kernel node? Is kernel node is a system which is working in the kernel space, and the other two nodes basically, which is monitor node and the control node. So monitor node consists of three things that we haven't worked on that because it's our future work and also we are extending it to the major project. It will consist of three monitors which will be distributed in any part of the user space, so that the attacker, if they are getting one of the monitor node, they can't get another node because they are not linked with each other. They are working independently, and we have developed the control node which is the last node for us, which gives us the health checking, creating a baseline, also creating a complete report. So with the based on that report, the user will get a prompt that your kernel is being breached, or you have a module that is trying to load in your system. These are the things that can be given from the control node. So there will be a major question for us, that how we are making sure that this system is a secure system. So for that answer, I would like to say that currently we haven't checked any of the benchmarkings. So without benchmarking, we can't say that our project is the optimized and the very good one. But the thing can we say is that theoretically our model is giving us like 4% overhead. That is very low, which is there in current systems have like 5 to 10% overhead. So it's basically low theoretically. And security, we are making sure that the UEFI, before our module gets loaded, before that the kernel is not malicious. That we are not reliable on. If the kernel is not malicious and after our module gets loaded, there is no chance that any attack vector can breach that. But we never know. There can be some attack vectors that even we don't know as a security analyst. So let's dive into our solution. Firstly, we are working on a VMware workstation. So I have used this for creating a virtual environment so that no one get harmed. So firstly, I will start with terminal, and it takes times. So here is the thing. So firstly, I will go to my. So you can see we already have implemented two among three things. First, we will go to attest lkm, which is our kernel node. So currently, I told this is presently working in the kernel space. So we can't directly communicate with that. We need something that help us to communicate with that. For that, I have test, which I have used AI to create this attack simulator, monitor test, other netlink test, so that we can communicate and say that our system is working good and fine. And I will like to show you that our system is already up and running. So with this, you can see that our system is already loaded. Previously, when the OS gets boot up, then you can say this is a active with like 14 minutes ago, as I have already started 14 minutes ago. And for looking the logs, we just go and grep the attest and I will give my password, and as you can see, it's giving me the logs. And so here are some a module load attempted, something like these are the logs that I am getting. Okay, there are some logs generating that says that any module is trying to get loaded, and it's getting detected. That's a good part of my project. So with the starting, I will like to start the attack simulator first, because other two will already pass because monitor node is working correctly. And if the attack simulator is not working, then we can just check with the other things. Let's check. First, it will check the hash integrity and it's matching. So it will start checking the module. So here what I have done is I have already created a .ko file, already signed already I have signed a key that can be used to insmod this dummy. So with this, you can see there is also rapid mode, so that if somebody tries to rapidness and we can't detect that, so that will be a failure for our attached LKM module. So we already have checked that. And lastly, you can see we have total of alerts like 20, and already all the 4 tests are passed. So first test pass is hash consistency, second is module load and module unload, and last is rapid ops. Rapid ops means when we are like rapidly want to load and unload the module. That is the thing. And now we can say that our module is working correctly. And for this module I have used C for, as we are working on kernel mode. So C is being used for this creating of this kernel module. Now I will go to the control node. So control node, if we want to start this, as you can see there are lots of Python files. So I will clear this, that I am using here is Flask server, as we just want to get a API. By using syscalls we can get the data, but we can't show it to the user, right? For that we are using APIs, so that the user can get a very easier version of the complex messages that are coming from the kernel. For that I will start the Python server like this, and I guess if just I can just do this. Okay, if I can do this, it will just start. Okay, so you can see the public key for monitor 1, monitor no, monitor 3. So already I have created the public keys, but I haven't created the monitor node, so it's not, it's basically, it says that we have loaded that. And also you can see here is logs. So all the log that is being generated by control node, it will be stored in this. And there is also two things, one is report and one is doc. So report will generate when the each monitor will generate one reports, and based on that our conscious algorithm will say to the user that your kernel is being breached or it's just a fake. Okay, and if we want to check this, we can just directly go, like Firefox will open, and I can show you. Just give me a second. Firefox is opening up. I'm opening it. So here we can just directly go and run, right? Then we can just check the status. So you can see total monitors are 3 and quorum is 2. So there are no updates. If you can just see here, there is no baseline created, as we don't have any attack right now. And I can just copy and paste, and I can show you the baseline. And there is no baseline established, as there is no attack. I can show you the healthy because we don't have any attack at this time. So you can see here I am getting a JSON raw data. Okay, and that's all. That's for a minor project. We have worked on this unique solution so that there is a also runtime integrity. So at present with this solution there are very less solutions, but they also have one common thing, which is single point of failure, which our system don't have because we have created a distributed system. That's all for the minor project. We will be completing this in the major project and will be publishing a paper with this very soon. Thank you for listening, and I hope you get our what is the project on, and I will surely say give a positive feedback and what are the things that need to be modified, any suggestions with the project, and lastly give a like and subscribe. Thank you.